Chapter 20, Problem number 14. A large spool in an electrician's workshop has 75 meters of insulation-coated wire coiled around it. When the electrician connects a battery to the ends of the spooled wire, the resulting current is 2.4 amps. Some weeks later, after cutting off various lengths of wire for use in repairs, the electrician finds that the spooled wire carries a 3.1 amp current when the same battery is connected to it. What is the length of wire remaining on the spool? So in order to solve this problem, I use these two equations. I use this one right here, which is the resistance is equal to the resistivity of the material multiplied by the length of the material divided by the cross-sectional area. And my second equation that I used is Ohm's law. And I knew from this problem I was only given the length of the material and the current, and so I wanted to figure out the relationship between the current and the length. And so from this equation I divided both sides by the resistance in order to get this right here, so I have the current on one side. And I know what the resistance is equal to, so I plugged in this R right here. So let me just rewrite this right here. And again, I'm just plugging in this R, or what's on the right side of this equation, right here. And from here, I'm going to rewrite the equation again, just to make it a little neater. And I now know the relationship between the current and the length of the wire. And from these two equations, I was able to come up with another equation, or this one right here. First current over the second current is equal to the length of the second coil wire over the length of the first wire. And from this third equation that I was able to come up with, I just plug in the values, and so the first current was 2.4 amps divided by 3.1 amps is equal to the unknown length over the known length, which is 75 meters. Multiply each side by 75 meters, and I got the unknown length equal to 58.1 meters. Again, going back to the two original equations that I had, I knew that the resistance was equal to the resistivity of the material times the length of the material divided by the cross-sectional area, and I had Ohm's law, and the whole point of these two equations was to determine the relationship between the current and the length, because these were the only two values that were given in the problem. And once I determined the relationship, and the relationship is that they are inversely proportional to one another, I was able to just come up with this equation right here, and from here I just plugged in the values, and I got a final answer of 58.1 meters.